This. So I might have to mute everybody if the feedback gets bad. It looks like that's the case. All right, y'all.
Okay. So
okay. So again, while everybody's here, maybe you heard this. This is called a double-ended stem and leaf plot. And the middle numbers, like a spine, the spine represents the tens place digits. Okay, so 0, 10 place, 1 would be the tens, 2 would be the 20s, these are the 30s, the 40s. So down here for class B, the 40s would be a 41, 2 44s, 2 45s, and a 47. Okay, now put that on the whiteboard back here. All right, so you can see on my bloated up screen here that that's the case. All right. And so what we want to do is you want to find the mean and the median. All right. If anybody got the mean or the median, you can go ahead and shout that out. And we'll go over this in about a minute. Okay, so again, this is a double-ended stem and leaf, and we call the numbers in the middle the spine, and that's the tens places, and then the numbers on the left and right would be called the ribs, and those are the ones place digits. All right, so the spine and the ribs. Okay, now I'm gonna go ahead and stop the share, and so here you guys can see what we got going on. So anybody get anything out of this? I mean, it's all good. I'm gonna go over it in a second. Okay, so first thing you gotta do is count how many numbers there are. And so over here, there were 25 numbers. And over here, there were 20 numbers. So these are two different classes. And this was a 50-point test. So notice no one got 50. No one got a perfect score because there was no 5s, 10s digits. So the highest score here would have been 48 in class A, whereas the highest score in class B would have been 47. All right, and notice no one got a 0. Hey, that's good. All right. Now, if you want to get the mean, you just add all these numbers, divide by 25, add all those numbers, divide by 20. And remember, you got to include the tens place digits when you add the numbers. All right, so you should get 32.28 as the mean for class A and 30.8 as the mean for class B. All right, so it appears that class A did a little bit better, right? About 1.5 points better, but that's an average, and that might be skewed by a couple people who did really well. You can see that might be true. A lot of people did pretty well. You got a 7 and an 8 here. All right, whereas over here you only had a 7, so 47, whereas here you had 47 and a 48, so that could have skewed the average. All right, so let's go ahead and find the median. That'll be a more balanced approach. It'll be less affected by the skew of the value. Let's see if we actually have similar classes here by using median. Okay, did anybody get the median? Take a sip of water. Cheerio. Okay, so let's find the position of the median. We got 25 numbers here, 25 students. So if we ranked all the numbers, then we would want to find the position in the middle. So 25 plus 1 divided by 2. So that would be 13. Okay, so the 13th number. Whereas over here, we have 20 students, 20 numbers. So we want to find the middle of the 20 numbers, ranking them in order. And so 20 plus 1 divided by 2, so 10.5. Okay, so we want to be in between the 10th and the 11th number. All right, so now we're going to count. Notice I put these in order going left to right. So we're going to count going left. All right, so 3, 4, so 1, 2. This is 13, so that's the third number. Now, we can't start counting here at the 8, because then we would be counting out of order. So we got to start counting over here from the 1. So we're going left to right, down, then left to right. So the third number, fourth number, fifth number, sixth number, seventh number is 25, eighth, ninth. Okay, so the 10th number would have been 32, right? 11th, 12th, 13th number is 35. Okay. Now counting class B, we want to find in between the 10th and right, you got it, Ryan, in between the 10th and 11th numbers. So again, we're counting left to right and then down left to right because we want to count from lowest to highest. So 1, 2, 3, 4, 5, 6, 7, 25 would have been the 7th number. 8, 9, 10, 11. So the 10th number is 33, and the 11th number is 35. Okay, so then 34. All right, so class A, 35 was the median. Class B, 34 was the median. Okay, so there was a difference here. So we do have some evidence that class A was a little bit stronger. It wasn't just skewed by the average because the median also shifted. Yep, you got it, Zachary. If you're in between 3 and 5, remember that's between 33 and 35. Okay? Any of y'all out there in internet land need anything? All right, so let's look at the homework. And so here, now maybe you decided to pick your intervals and just went by 5s or 10s. Maybe that's how you decide to do it. Let me share a screen. I realize I didn't do that. Sorry, y'all. Let me see. What am I doing? Boom, boom, and share the screen. All right. So maybe you decide to create these intervals in some arbitrary fashion. No big deal. But again, here is how we can systematically do that. Remember, you take the largest and the smallest number, subtract, and divide by how many categories you want. Well, there were 7 rows here. So that's why I divided by 7. And I got 6 and 4, 7. So I rounded that up to 8. Now, maybe I could have rounded that up to 7. Okay. I just rounded it up to 8. And then I started with the smallest number, 44, and I added 8 going down. And then once I got to 84, I put 92 here because that already contains the largest number, which was 90. So, all right, so I didn't really need the 7th row. Now, maybe if I went up to 7 instead of 8, that would have been different. Okay? So I just counted the frequencies, and then there was a total of 15 numbers. So your fractions, your relative frequencies are going to be based out of 15, right? Notice I'm just dividing the frequency by the total, and then I converted those to percents down here. Okay, and then over here, the same kind of thing. They gave you the frequencies, so you add up all the frequencies. That gives you the total. So 20, there's 20 numbers represented in this table of number of free throws. There's 20 free throws that were represented. So we based the relative frequencies out of 20, frequency over 20, converting to the percents. Okay, then here I put the frequencies on top in the red numbers so it's easier to see. Now, these two histograms represent different ranges. So histogram A goes from 0 all the way to 50, and histogram B goes from 0, but it ends at 40. So A has a wider range. And if you want to find out how many numbers are represented in these histograms, you add all the frequencies, these red numbers, and it wound up that A had more. Okay? Now, skewed means how many more on the side of the mode. Okay? So if you look at histogram B, there's more numbers to the right of the mode. So that's skewed right. Whereas if you look at histogram A, there's more numbers to the left of the mode. So that's skewed left. Okay, and so that's really what's going on here. So the reason why part D, I picked A to have a higher median, because the mean is going to shift in the direction of the skew. So left skew, the mean is going to shift to the left. Right skew, the mean is going to shift to the right, right? Just like the warm-up. The mean was less than the median for both Class A and Class B. All right? So the data in the warm-up for Class A and Class B is left skew because the mean is shifting below, which means on a number line to the left. All right, so just to relate back to the warm-up. All right, and then here, this second page, you can see that the numbers are ranked, so that's cool. And I did the same thing, highest minus smallest. There's still 7 rows, empty rows here. So that's why I divided by 7. And next time I got an integer. So I used that exact number, 17. So I started at 55, added 17 going on down. And then once you add 17 to get the last number, it's going to be exactly the same as the largest number, because we had an exact range interval here of 17. That didn't happen up here. Up here, I rounded this up to 8. And so the last number in the last interval was not the same as the largest number. Right? Here it was. Okay, and that's because I used the exact number here when I calculated how to create these intervals. All right, so the same thing, and here this total was 18, so the percentages, the frequencies out of 18, I converted to percentages. Okay, and then down here, these last couple questions. So if you look at this table, this represents people who were attending a new movie, and notice that there's a whole lot of people between 0 and 20 in age. There's much less between 30 and 45, and there's a few between 65 and 75. So to me, I look at this, I see youngsters like y'all, I see parents, and then I see grandparents. So that's what that looks like to me. So that's to me is why I said for question letter E. All right, so the frequencies, I put the numbers on top, right? So you add all the frequency numbers, right? So there's 191 people represented in the sample. Some are younger, 20 or less. Some are older, 30 to 45, and a few are much older, 65 to 75. Okay, so where's the median located? If you ranked all these people by age, what would be the median age? So we know we have 191 values. So what's the middle number going to be? It's going to be at the 96th position. So if we rank these people by ages and count it all the way to 96, that would be the median. All right, so let's use the cumulative frequency. Where's the 96th number going to be? Well, less than or equal to 10, we got 65 numbers. Less than or equal to 15, we got another 65, so that's 130. So the 130th number would be in 10 to 15. The 65th number would have been from 10 to 5. So in 10 to 15, we have the 66 to the 130th number, which means the median is here. And notice the median is shifting to the right of the mode. And notice that we have a whole lot more numbers to the right of the mode, so this is right skewed. You got a few people who are much older than everyone else. It's going to skew the mean. All right, that's what that means. All right, now down here, if you look at this bar graph, this histogram, this is kind of symmetrical, right? I mean, granted, this fourth bar is 5 more than the second bar. That's true. But if we had another sample size of 1,000, if we doubled this sample, that might balance out. The second and fourth bar might balance out. So, okay, so this is called central or roughly symmetrical, which means the middle number and the mean are probably going to be in between 15 and 20. Since it's symmetrical on both sides, it'll balance out. So that's why I picked 17.5, and I know you guys probably got E. And then once we want to find the percent that's from 15 to 20, so when we add all these numbers, we get a total. So there's 110 cars represented in this histogram. So what's the percentage of the 35 in between 15 and 20 miles per gallon out of 110 cars? Here's the problem, and then you just convert that to a percent. Okay? Y'all good? All right, so it's time for a quiz, all right? Which means there's not going to be any homework today. All right, well, let me just rattle off the names, make sure I got everybody, and then I'll sign off and I'll email y'all individually. It'll probably take 5 minutes, but once you get the quiz, you have an hour, okay? And again, I won't be finicky if it's an hour and 2 minutes more. Take a picture, send it back, okay? So I got Trinity, Bryce, Donnie, Zachary, Ryan, Nakor, Youssef, Lily, and Aiden. Am I missing anybody? And I got Joshua too, okay. Okay, so Josh, just follow the protocols, okay? You know what I'm talking about. All right, I'm gonna go ahead and stop the share. I'm gonna go ahead and get out of here and start emailing y'all.